I am fine. Lucky to be amongst you.
Glad you can make it.
Thank you very much.
Hi, Sam. Hi, Sam. I didn't see you there.
He's getting set up. So when you feel like doing a little project review, so tonight I thought maybe we just do a update to see where everybody's at, and then Sam's going to lead us in kind of a discussion on the minimum viable product. We've kind of been away for that for a little bit, maybe touch base and see if we know a little bit more.
Of course, yeah. I don't have any recent pictures because we've been busy doing stuff. We haven't done any documentation, but it's basically hardware. I've been putting together stuff. So yeah, I don't know when we're gonna do the test run, but I'm really pushing for it. Like I'm really asking everyone to get done with their part, and so I can actually run it. Let me get my phone, and I think I'll have some pictures.
Okay. Colin, you want to take a moment and introduce yourself? Thanks for joining us. I know it's 3 a.m. where you are, so I appreciate you making the effort to be here.
Well, thank you, Matt. I am a newbie in these things, and I thought what I would rather do is listen to all of you guys, pick up a thread as to where I should start from. Basically, my keen interest is to convert my tractors and my planters into autonomous vehicles. I hope one day I will be able to. I've been in touch with Matthew Raymer. He gave me his source code for his bean cut. But there is quite a lot that needs to be understood before one can just run those codes. So I really need to learn a lot. I've got a little bit background in programming in Python. I've completed a course with Coursera, and just completing another one with edX. The same one as Matthew Raymer took. So I'm hoping that I'm not technical, I'm a chartered accountant by profession. So you can imagine the gap between where I want to be and where I am. So I need your push and I need your help. I think that's basically it.
Matt, you're on mute.
Yeah, I can hear you now.
Yeah, thanks for being here, and don't worry about being a newbie. We're all learning what it takes to get these things moving around.
Thank you very much.
It's 8 o'clock, so we can get started here. So it looks like maybe we'll have a couple project reviews, maybe Al and Soen, and then Kyler's been doing a lot of work getting ready to plant. So if he jumps on, he could still be out. Or
I'll just need a few minutes if you don't mind.
Al, do you want to? What was that?
If Al wants to go first, I'm okay with it.
Okay.
Okay, I'll buy you time. Just you go like this, and I'll stretch it out.
Thanks. I really appreciate it.
Let's see. So I took a couple of screen clips. Let's see. Share screen. So my platform is this John Deere 5055 tractor. Hope, just to confirm, Matt, can you see my screen? Okay, cool. So my steering solution is based on having a geared motor effectively sitting right on top of the steering wheel. I've also tested, but not really put into production, a linear actuator pulling back my clutch and brake here. That silver thing there is a linear actuator. A little bit closer photo of the steering control is, again, this 12-volt geared motor driving this 3D printed disc, which sits on top of the steering wheel and is held in place by this steel bracket that's been fabricated for me. I have put together a little bit of a list of milestones that I've been driving to, and all of this is in the G drive, by the way. So this is just a clipping of the data. So for me, I spent time to get the teleops to drive, you know, the TurtleBot, to use a Logitech gamepad to drive it in the visualizer in the virtual world, connect the RPi and drive the tractor from a disconnected, you know, from a remote position on the same network, connect the GPS and visualize the GPS. Again, all this is sort of virtual, right? Not in the real world, but in the simulated world. Connect an IMU and visualize the results. Test localization, combining the IMU and GPS data. This is the step that I'm at the moment, although I have also, with the tractor, tested steering using a Ross published steering command, and that's some of the code that Kyler and Matt helped produce for my motor controller, which drives the 12-volt steering motor. So all of that is either on GitHub or in the G drive. And so then I've got these next steps, and where I'm trying to get to is to test my tractor, you know, running a very simple 2-point A/B line test, and try to do it within plus or minus a couple of inches. So using RTK, GNSS, GPS signals. So that's my plan. My progress is basically up to step 8 and 9, and you know, I'm looking forward to finishing these last few steps. This little clip, again, I've been trying to document my path so that hopefully, you know, anybody can replicate my steps or use my steps as an example of how at least I did it, and which hopefully would accelerate their process. So my current challenge, quite honestly, is I'm on step 8, testing the localization. When I run this particular node, I'm getting this socket error, and Matt has been trying to help me find somebody who can help resolve that. So I've got 2 or 3 different paths to try to, again, complete step 8. But right now that's where I'm at. So wish I had more time to spend on it. This is all, you know, I have a day job in information technology, and that keeps me pretty busy. And so I struggle to find all the time I would like to do to spend on that.
Can you scroll up, please?
Tell me where to stop, Soham.
Yeah, here, right. I just wanted to see what. Yep. Okay. What kind of GPS are you using?
Does that device exist?
Does the device exist? I mean, I can cat the output, you know, to my, you know, I can cat the output, so it's connected and producing output.
What kind of device is that?
It's a US. I've been testing this. It's a who makes this? Daggone it. This is what it looks like. It's a USB device, $60 or so on Amazon. Model number BU353S4. It's got a surf chip in it.
I mean, if you're just connecting over serial, wouldn't it go under TTY?
I don't understand. Ask that again, so when you sort of cut out.
Oh, sorry. If you're connecting over USB, wouldn't it go under TTY/dev/TTY?
That's correct. I don't see the TTY either.
Yeah.
You're right.
I've got a UDEV rule, and so this GPS is pointing to the TTY USB 0. Good catch, though.
But did you try that? Like, you can maybe try doing directly over USB TTY 0 and then see if that works. Maybe I don't see the point in going around that.
Yeah, I copied this, but yes, you're right. I've tried both using the UDEV rule and directly putting it in.
The point of doing that, Sohan, is that he might have another USB device that shows up like a TTY, and this disambiguates it, so he doesn't have to change it in his code everywhere every time he plugs them in the wrong order.
Not that I would ever do that.
I have a GPS that shows up as 2 different TTYs, and then I have other things that show up, so it gets real confusing very quickly if you take the hard code approach.
Did you add usually those devices add in the dial-up group. So if you don't have permissions, you'll have to run a sudo, which is probably not recommended, but you can add your user to the dial-up group and get permission to that device.
Yeah, Matt and I were trying to debug it on Saturday, and that was, we definitely found that out in the domain to say, make sure you're in the dial-up group, and that, we worked through that.
You said you were able to cat it, didn't you?
Yes.
Okay, so that takes care of everything. I mean, it's coming out.
So my next step is to try to get it working on an RPi and, effectively see if it's something wrong with my particular Ubuntu laptop. And or to make sure that I'm getting a strong enough GPS signal, drive it around in a car. So that was my next couple of debugging steps. Plus, Matt also wrote a question out to, was it Ross Answers, I think, to see if anybody else had any thoughts.
Yeah. Can I share an email with you so that I can follow what you're trying to achieve with what I also want to do? I think what you have done is actually very good. Putting steps and program in place of what you want to do.
There you go.
Let me.
Plus, we can message back and forth in the in Slack as well.
Okay. I want to take a picture.
Just to be clear, though, Kyler is way ahead of me.
When I have a follow-up question. When you run this, usually you get a param list print when you first when you first do ROS run? Do you notice if your params that you're setting are in a printout?
Ooh, Matt might have to help me with this. So we printed out the ROS environmental parameters. I'm not sure what any other parameters you're referring to.
As soon as you type ROS run, it's gonna list a couple of information from startup, and some of that, usually it's the list of parameters that you're running with, and it should show you all the parameter values.
Mm-hmm.
Be on the screen, or I think you could, if you do, while it's running, if you type ROS cd space log, it'll take you the log, and you can run a grep command and search for it there. But what I would look for is the params that you're setting, making sure that those are set, because I'm pretty sure those are private params, and when you use ROS run, you may have to use the namespace or something else as a prefix to that. But
Jeremy might have to send you a message about how to do all that. But yeah, I think the answer to your question is no, I haven't looked for those params, but I'll do that post haste.
okay.
Another thing to consider is that socket error might be when it's trying to publish something out and not necessarily as it's trying to read it in from the USB. I don't know that that's a fact, but that might be happening.
What would you do about that, Jeff?
I'm not sure. You would just have to determine if that's what's causing it. Now, you did start ROS core first. The ROS core is running.
Mm.
Otherwise, sometimes when you start it, it'll say automatically starting ROS core. But I like when I'm experimenting, I'll start up ROS core in a separate window just to make sure it's running.
Yeah.
Because if it's trying to communicate out and it can't for some reason, it might give you an error like that.
Yeah, I'll go back and try that. I can state with about 80% confidence that yes, I've tried it running ROS core separately in a separate window and then running this, but I'll definitely go back and try that again.
Okay.
So anyway,
Al, do you know about strace?
Sorry, Kyler, no.
If you're a real masochist, you might want to try strace. If you're getting a socket error, you'd be able to trace down what socket it's having problems with. I'd recommend doing everything else first, but if you need help with that later, we can go through it.
Okay. If I can get it working on an RPi, what I will do is re-image my Ubuntu laptop and start again, because I just want this problem to go away. So I'm all up for the nuclear option here. If you guys want to point me in the right direction, but all good input. Thank you for that. But I mean, all in all, for a part-time guy, I'm pretty happy with the progress. And if you haven't seen it, Matt put together some slides on testing localization, and so I was basically trying to follow that and at the same time add to the documentation to make it even more simple for somebody like me. And it's all again out there on between the G Drive and Slack and GitHub. That's about it for me, Matt.
Thanks, Al. Great progress.
I can show you all some progress, but that's a week old. We've done a lot over this week, like over the last week, but I just didn't have time to take pictures because I was also struggling with finals. Anyway, yeah, I have some pictures. Let me just share the screen here.
Jeff, do you have some cheese to go with that wine?
Which actually, I don't have wine. It's rum and Coke I'm drinking. So.
Okay.
Okay, so this is like super old, where you can see this is the shaft that connects to the front wheels. What we did was, yes, it doesn't work that way. Yeah. And then we had stripped everything. Okay, my bad. It should be this. Right. Okay, you can see that now, right? Oh, cool. So it goes the other way. And then this was the old Yeah, that's the new one. I put the cables in here, and right now I have everything connected, but I just don't have a picture for you guys. Uh, yeah, that's how I have everything connected. So these steppers, they pull a cable that run around the chassis, uh, and I'm sorry, that's a different picture. Yeah, I don't have a picture from the front, but I'm sorry. I'll get it maybe next time. Okay, yeah, I can show you here. So these cables go around from the center console out here, and over here, whoops, you can see this bracket that's holding the cables here. We have some 3D printed parts. That's holding the accelerator and brake, and it works nicely. We had some trouble with the brackets, but we printed them in nylon and reinforced by carbon fiber. It was a costly print, but it works. Like, it's amazing now. And like it didn't cost us at all because we already had a printer at the university, so it was free in that sense. But we just used those resources. We also used tough resin, and we experimented with different materials to make sure that these materials are, as rigid as they should be. So this one right here is the emergency brake. As soon as you push at the push of a button, it would pressurize this compressor thing, and it would pull the brakes back to a specified. It depends on the pressure that you have. We found that 25 psi is the best pressure for that purpose. It pulls the brake completely, and it doesn't break the cable. So that works for us. And the steppers, they're facing in the opposite direction. So we have a ROS node. We are using Ackermann messages to just give linear X and Y, and then we're translating it on an Arduino to figure out the exact rotation, like the exact number of steps it takes for maximum. So we have a hard limit over software that would say, 200. We have 205 steps, so let's say 20 steps is 3 miles an hour. So that's how we have mapped it, and it works nicely. I haven't done this calibration yet, but that's something on my list to do on this Thursday. I'll keep you guys updated with that. I'll have some cool videos for sure for that day. This is the control box. We have this nice plate we made in house, and this was cut on a laser cutter, and then we used like L brackets off the shelf L brackets, $10 each, and we were lucky enough to find a plank that was of the exact size we needed, so we didn't even have to buy that, and we put it on there. It's on there right now, but I don't have a picture for it. This is an old picture. This is like old, a week or more than a week old. Yeah. Anyway, and this is the box that I got, $20, and it's almost weatherproof. Down there is the computer, and we have a nice acrylic sheet that distributes power over the Arduinos. This one should be, there's also an H bridge right now sitting over here, but I don't, this is an old picture. I'm sorry, I can zoom in. So this is where the H bridge is, and this is for emergency system, and it's just it connects to this thing connects to, I'm sorry, this guy right here. So, and there's a solenoid valve that's inside this box, and yeah, and we're drawing power from a AC/DC converter. It supports up to 100 amps, which is amazing. I mean, all you might need we used 100 amp. This is a costly piece because it's $180, but we use this because the steering, we're using the EPS system on board for steering, and it draws like around 40 amps of power, like current. So we wanted to have that margin. We didn't want to blow up the EPS because Yamaha charges $1,200 to replace it. So we didn't want to take it on. But this is all wired up. I can show. I'll show you a picture on Slack. But that's. Yeah, that's.
Are you using megas?
Yes.
Okay.
I mean, we could have used Unos, but I was like, why since we're paying for them already, like why not just go and have the bigger one? And then these megas come with a nice plate on the back.
Sorry?
Yeah.
What is the objective of your project? What do you want to end up with at the end of the day?
Sure. So this is the truck, and we want to traverse a field of corn, and then we also want to detect weeds along the way, and we're using a neural network to basically detect weeds, and then we'll have, so as you can see over here, we'll have these bottles just as a proof of concept, out of which we'll have herbicides being sprayed out of this ad bot. And the system should go around here. We still have to fabricate it. We have the other parts. We're using solenoid valves to just actuate, and the third Arduino is for the spray system.
Okay. So you have got 3 Arduinos.
Yes, we have three Arduinos because this one just takes the Ackermann messages and translates it to steering and actuation, like steering and throttle. And then this one's the emergency for braking, because so we realized that our robot just stops if you don't give acceleration, like in a few in less than a meter. And while you're going at speeds lower than 5 miles an hour, it was just over engineering if you went ahead and controlled the brakes as well with the stepper motor. So we just used the brakes for emergency cases. Like we'll just push the brakes if there's an emergency. And so this Arduino, what it does is it just receives a signal. And it's only subscribed to, it only publishes to ROS. It doesn't subscribe to ROS. So it's an independent Arduino, where what we'll do is it will have a Zigbee connected. So when you press, with a press of a button on the Zigbee, the other Zigbee will send a signal to this Arduino, and this will actuate this solenoid valve. And it will also send a message that an emergency has occurred on ROS. So the ROS system knows when to stop. But other than that, it is not interfacing with ROS. It is not subscribing anything to ROS. It just tells the ROS that an emergency has happened. It's just because we want to isolate that, and we'll also have an extra battery for this one, just in case.
And the third one? And the third Arduino?
I'm sorry?
The third Arduino.
The third Arduino is for the spray system, which isn't installed yet. We have a few people working on it to fabricate it. We're just using a trailer hitch to connect it. So,
okay.
But it's basically controlling solenoid valves.
I don't know, through you, Matt, I don't know whether Kyle can comment on what is needed for a tractor. I saw his tractors running around, plowing and disking and doing all sorts of things. And I was wondering how many Arduinos did you have to connect in those tractors? Is it necessary to have 3 or 1 is enough?
Well, the third one is for the spray system. It's an optional. So if you just want to make a tractor go, I think one Arduino is fine for acceleration and braking and everything. And I have the other Arduino just for emergency. So if you're not so much concerned about the emergency, then maybe you can eliminate that. So I think you can just use an Arduino. But the question is, do you actually want to go with the Arduino route?
Well, I haven't figured that one out yet. I'm still collecting information.
Yeah.
Yeah.
So, yeah, well, Arduino is an option, but there are also other options that you might want to consider. I think Al is using a Raspberry Pi, and you can also use an NVIDIA. I think it has GPIO. So if that solves your problem. In my case, we were just using, so we are using this computer, which is a surplus computer, and we wanted to save some money on that part. That's why we're using raw serial over Arduino.
Okay. All right.
Yeah, my companion computer is, my laptop, and then that's running Ubuntu, and then that's feeding raw signals to Pololu JRK motor controller. So I don't have an Arduino in my configuration at the moment.
All right, yeah, makes sense. So you're just using a Pololu controller over raw serial, and you're still using raw serial, right? So yeah, in my case, we were trying to control the steering on top of it, but we could have used a Pololu. Maybe, yeah, that would have been a good design option.
Well, again, I'm not sure I'm going to get the accuracy that I want, but that's the current configuration.
So, how do you know how much you want to turn?
That's Matt's smiling because he's going to tell me how much I need to turn. The honest answer is, well, let me see if I can.
It's magic.
Yeah, it's magic. It's or Kyler's other favorite saying, "Oh, it's easy. It's easy."
It really is. It really is.
He says that.
Pure pursuit. Use Ross transforms. It's easy.
I mean, so can I digress for a second, Matt, and just use that to segue into the.
So you're how do you calibrate steering? Is that the next question?
We have a system set up, but I was curious to know what else doing for that.
Okay.
I can show what we have after this.
The honest answer, I mean, this is the flow chart that I went through once before. Some folks were on, some folks weren't. So you read a waypoint, you make a steering correction, and this box, make a steering correction, is exploded here. I think that steering correction is going to be calculated using, as Kyler mentioned, this algorithm called Pure Pursuit, which this is a little bit of a write-up on that. I haven't got to that point yet because, my step 8 is just to get localization organized between the IMU and GPS. But Kyler promises me this is simple, easy. Anybody could do it. Like, he's frustrated that I haven't already gotten it done, So this is where we were headed, or at least I was headed. And again, this is in the minimal viable product folder on our G drive.
Yeah, in our case, we're just using, so we 3D printed this part. It's a gear. It just attaches on top of the steering assembly. And then there's an encoder behind this. I don't know if you can see it very clearly, but there's an encoder over here. and that encoder reads the value every time you steer. And we have a software limit for both the sides, and that's how we know how much we're turning. So if you want it to be at 45 degrees, you just put in 45, like you put in the values in radians and it turns. And we've just made sure that we use Ackermann messages, so it's all ROS compatible. So if an Ackermann message sends in like, turn this much, turn by this many degrees, it would just do that.
And I know you're
left and right.
I was going to say, I know you're time constrained now to get through, the competition and everything and studies, but at some point it would be useful, I think, to dig into that a little bit more and walk through that code.
Yes, I would definitely love that. Love to do that. So I'm in my case, I'm almost done with my master's degree, and I'm hoping to graduate this December. And I'll have a lot more time over the fall semester to just document everything that we did for this project. And that's my hope, because a project this project wouldn't mean anything if there's not enough documentation for other people to just go ahead and improve it. So I would definitely love to walk everyone through that, and I'll make sure that the documentation is not subpar.
Cool, thank you.
What is spraying SWOT are you aiming at?
I'm sorry, can you say that again?
What is spraying SWOT of the spray are you aiming at? The width of your spray.
The width of the spray? I'm sorry.
Yeah. Is your project just going to identify the weeds that you need to spray?
Yes.
If you're going to spray, what weeds are you going to be able to spray?
Oh, definitely. So we are supposed to detect three kinds of cornfield weeds. The first is common ragweed. Sorry, the first is giant ragweed. The other is redroot pigweed, and the third one is cocklebur.
Okay.
And we have to differentiate between each of these three weeds and spray. So put a point application of the herbicide on them.
Oh, okay. All right. Okay.
Yeah.
Interesting project.
Thank you.
Thank you.
So yeah, I think that's all from my side. It's an older update, but hopefully next time I'll be ready. If Matt asks me to do a on-spot
It
presentation.
looks great. You guys are making awesome progress. It's fun to see the pictures as they go along, as you're getting closer and closer as it's coming together.
Oh, it looks way better right now. I feel so proud when I see it. I just wish I could share it with you all right now, but yeah, it's really interesting. It keeps us busy.
Thank you. Kyler's been doing a lot of work with his tractor, getting ready to plant. It looks like he was out in the shop. Today we set up some GPSs, some SwiftNav, the multi, and those actually came together pretty good, pretty well. Able to get RTK fix quick and worked okay. I did some mapping in the field. I tested some of the old Pixies, and the best I could get was RTK float. I wasn't able to get them into fix.
And were you able to hold fix on was it the SwiftNav?
The SwiftNav multi did drift in and out, but for the most of the time they were in fix. Yep.
And were you using a pair of SwiftNavs for a base and a rover, or were you using corrections from cores?
Corrections, and then one unit on the rover.
Can you explain the difference between the correction and the base station and rover station? Yeah.
Kyler will probably be able to give a better explanation of it. But to get the RTK, you have to have correction data sent to adjust your position. And so you can set up a base station and then have that surveyed point, and then that base station GPS, it's another GPS, can send corrections to your rover, or you can get it from a correction service that will send you the data, send your GPS the data.
Got it. So you use the service.
Those corrections are atmospheric corrections. So they're your local atmospheric conditions. So you want to get corrections from something that's fairly nearby. So that's important. And West Lafayette has a correction station, incidentally. Oh, wait, you're in Indianapolis. I'm sure they do too.
Yeah. I didn't go, I haven't looked at it yet. I'm just trying to make it move first, like, with a command. And then I'm just depending on you, honestly, to have the waypoint navigation.
Sounds good. Good luck with that.
Is that a sarcasm or?
I'm depending on me to get this stuff going, and yeah, it's been a challenge.
I think I might have the localization data soon. I just haven't thought into it. I read through this robot localization wiki. I went through it like 3 times now, so I know how to configure the parameters. It's just I just need to do it for real, and that's about it. I know what kind of matrices I need to put in and how. I haven't tweaked with the covariances, but I'm really hoping to get the sensor fusion done, so that, because I don't have an odometry coming in, and I just have an IMU and a GPS. So yeah.
Good luck. Matt knows how to do it. Even with Matt showing me how to do it, I couldn't do it for an entire day. So
there's some really bad documentation out on the Google Drive I can send you. And
yeah, anything helps.
The parameters I used and the setup is on the GitHub.
I saw that. I have to try it.
Okay.
But yeah, thanks. Also, I had this question. I saw this post on Ross Answers, and did you go through that, or did you just use? So, what exactly are you using the EKF localization, or are you using it along with the NavSat?
Both. So this is the part that kind of gets weird. How it's almost circular, where you're trying to
right?
Yeah, and how it works, I don't know. The math behind it, no idea. But if you follow the steps, it really does work. Amazing. I don't know how.
Yeah, I made it to work once, and then I had to switch computers, and on the other one I couldn't make it work. So I'm just confused. But any documentation that you have would help, and I might even message you if you don't mind on.
Sure. Absolutely. I can send you a link to that, kind of just a little write-up, and then it's all in that launch file is the things that I'm launching to get that to run.
Yes. Yeah, definitely. That would be helpful. The other thing is, what's your next step after this? How are you planning to do a waypoint navigation? Or
I could share a screen and show you some of the Auburn. Do you want to see the Auburn planner? I don't know yet. I'm still trying to learn how it works. I'll give you an example. Here's a demo. So if you want to, I don't know if you can see the screen, but if you want to do like a shape, this is just a map inside of RViz with stage as a simulator. And then you can draw a polygon or send a polygon shape to this is the heat maps the Auburn coverage, and then it'll do area coverage pattern for you, and then send the move commands. And these are basically just GPS coordinates of the start and stop.
And how about the turn part?
Yeah, well, I don't know how to do the turn part. This robot can turn in place, so you know, your robot's not going to be able to make this corner here that it planned for it.
Yeah.
But this weekend we're going to learn more. Have a class about outdoor navigation, and then recording these waypoints. Now this one just automatically plans and fills the shape, and it takes the end waypoints and then passes it in each time to the move goal, the move base, and then it plans it.
So that's based on the navigation stack, I suppose.
Yes, that's based on the ROS navigation stack. Yep. Are you planning on using that?
Yeah, it's an option. I haven't figured it out yet, but I definitely want to use something that's already being done.
Can you post a link to that Auburn planner?
Yep.
I guess I could go look it up myself, but if you already have it.
Kyler posted a nice video of planting a dry run in the Slack channel. Okay. So Sam's put together a presentation on the minimum viable product. We got 15 minutes left here, so it'd be good to cover, kind of just give an update of where we are and what steps we need to work towards. Sam, do you want to hit that?
Sure. Lots of good work, you know. I can see over here, everyone's making progress. Actually, I see the Sohins, you know, like probably at the kind of an end of the project, and it's got a good traction actually. So, and also I was actually making progress, and all the direction that I'm looking at right now is just everything's pointing into the right direction actually. So what we're trying to solve for the MVP, and then actually over the last 2 weeks, you know, what we talked about, I have been going through exactly the same thing, like the robot localization, the package that I, you know, had to go through, and what Sohin said, you know, that he went through 3 times. I may have went through like more than 3 times. And it has lots and lots of info, you know. I highly recommend REP 103 and REP 105, which is like everything what, you know, the RS explains in terms of the coordinate frames. Very important for the localization and what you use the EKF, like the local versus the global localization, where if you don't have the odometry data coming in, and if you're using the IMU, that's what they're saying, that then you can use that for the local localization, which is kind of gives you the kind of an ODOM frame, versus the other one, if you use a GPS and fuse that through the nav set, it would give you probably the map frame, you know. And then if, of course, if you have more than one vehicle, you know, you might need the earth frame, which in our case, I don't think so. We are that complex. Okay, let me share my screen. And I have put together, like, based on all of these inputs, and we had like a couple of projects that I looked at, which is the URC challenge, which is the part of that RS rover that one of the Canadian teams designed. Let me share my screen. So basically, and here is something that Bill had that one PDF put in as in part of the component graph. And what I did is I took that and took it further. And basically MVP to us is something that we can actually develop, and the MVP, the minimal viable product, it's just something that we can make it work. And it has the minimal bells and whistles, that's what I think at this point, but these minimum requirements are not so minimum. So let me just go through like all these systems that I'm thinking right now, and obviously I need lots and lots of inputs based on all of these experiences, what we are sharing actually. So the MVP to me is like, now we're going to use the IMU and GPS, and that makes my odometry system, obviously. So we're going to use the localization with that. As far as the drive input is concerned, I'm thinking about the joystick, and then also we will have the CLI, which is like the command line, the interface where if you wanted to actually put in some file directly, if you have the waypoint file, and if you want your system to follow it, that's one of the option. And the GUI is just basically graphical GUI. So it means that once you localize, and if you have the point in the map and your vehicles, actually is just being displayed, we can have a GUI where you should be able to draw, the kind of an fence, or also based on some algorithm, you should be able to, use those tracks. Kind of draw those tracks, or whatever you could do with the GUI. And then that's basically what I'm calling it as an drive input system at this point. All of this, actually, the component, they should use all the standard ROS messages. I have not come across any of the systems, at least what we're trying to build in terms of MVP, which would not use the standard, the ROS message types. So that's for the drive input system. Now, the e-stop and the remote kill switch is basically the part of the emergency, the stop system, and also that system and the obstacle detection system at this point. What I'm thinking is LiDAR is also, it's just kind of a kill switch, which sees something, and then it says, okay, well, stop. And so they both are providing the stop signals, at this point. That's what I'm thinking. Also the visualization system is very important. So it means that we should be able to visualize, the whatever we have, like in terms of localization, should actually go to the RVs. If at all, if you wanted to use the Google, the frames, the tile frame, then I think MapWays may be a good option, that we may be able to incorporate. And I'm putting in, as in part of the visualization system, I'm putting in like USB cam. So it's just like what tractor sees, you see, basically it's just a simple, the camera just for the visualization, that what you're looking at in the field, and then that everything's just, working good. Now, the main thing is the navigation system, which in this case, we're not using any of the, the standard navigation stack, but this would be based on the path planner. So it means that this would be kind of a PR pursuit kind of a system, just similar to that. So it means that once you have the input, your path planner, would decide and then actually give out this the CMD well, basically the twist messages out, and then which would technically drive tractor. Now, as in part of the actuator system, obviously I'm putting in, like right now, the brakes, steering, and the throttle. So as soon as I have the PWM outputs, or the twist outputs, and as long as I'm able to convert those output into whatever the the end actuating system that I use, I should be able to run it, all the actuator systems based on those outputs. So kind of an overall idea about how our MVP should be looking like, and then just to actually give a little bit deeper dive. I mean, what I'm trying to gauge is right now that how much work that we need, and what would be the custom development work that we might have to do. I don't say it like at this point our goal is like everything what we design is we should leverage one way or the other. All the packages are there. I mean, we're not going to actually reinvent the wheel. So the questions I'm asking, once I have all of the systems, let me show you the template that I wanted to use. It's just basically, and that also needs lots and lots of inputs from you guys. But what I'm saying is my first system, basically, if it's the odometer system, and I got the the components like my GPS, my IMUs, if I'm using any the encoders or anything, that would actually go over here. And then I'm just trying to answer, okay, why this is needed. What's the ROS package that I can leverage off? I mean, is this a node? And in most cases, yes, because they have to communicate. And ROS, everything's a node. So it has to communicate from, a point, one node to the other. What kind of message type that this, the component will be using, hardware use, so which hardware that it would be using, I mean, is a pub, I'm actually asking over here that this component or the node is a publisher or not, is this component is a subscriber or not, and then that helps me actually visualize that how many actually the topics or accents or whatever the services that I have to design, what would really be needed. The localization needed is just basically for the autumn and the frame, the map frame. So if you have the base link, obviously, and then you have to actually, if you're actually using the EPF localization, you need to have the map frame and the autumn, and you can make the autumn as in world, but because since we have the GPS and we have the accurate GPS, you might want it to do the localization with the GPS, the global, and then have that fix into the map frame kind of deal. So I'm asking that which frame that this would be help, which frame that it would help to. It would be the part of the base link, or would be the part of the map frame or the autumn. The parameter initialization is like if this is going to actually need any parameter initialization. It has any launch dependency. Is visualization needed? It's just basically the visual, the part of it. Is this critical? Over here, what I'm asking is just basically, when what's the minimum, what are the minimum components that I must need if I have to drive the vehicle, the tractor, and if nothing, if it's just not the standard, the part of the ROS package, then is the custom development needed and all the miscellaneous notes and stuff, So this is like I'm trying to visualize, overall scope of work, basically, and then between the components and how they should interact with each other, kind of deal. So here's I tried, and this is just for the example. So don't just take it as this is some, the fully thought out the inputs. But let's say, for example, if I am actually doing the odometer system, if I have the IMU and GPS, so I'm just writing down the whites is needed. So my IMU obviously would just give me 9 degrees of freedom, and my GPS, I would use it for the location. And there are ROS packages. We know for the GPS that we will have this NMEA package, and they both actually are a node. Their message types, so we know that the IMU would have my sensor messages IMU, and my GPS would have this navsat fixed messages. Hardware use whatever the the GPS that you have. In this case, I just write down the generic MPU 9250. You can have any IMU that. So Razer IMU is just one of the popular ones. There are some other IMUs that you can use. It doesn't matter which hardware, as long as you know that how the output is and how you want it to configure that output to. And everything's adhered to like REP, which is like 103, and REP 105. So if you can go through those documentations, you would know that what kind of coordinate frames that it would require. And sometimes it would spit out some different coordinate frame, and then you wanted to actually convert that into the RS compliant the coordinate frame kind of deal. So he's a publisher and say yes, yes, and he's a subscriber. I just put it over here. No localization needed. Yes, for IMU and GPS both. Which frame over here? Then I'm just writing down over here autumn and the map. the parameter and launch dependency, and all the usual stuff. How this would help us to actually figure out, if we have any custom development work, what we need, and plus all the nodes, and all the message types, at least at the high level. So we know that what's the flow like going from one node to the other, and what would be the kind of an end result, So that's what I'm just trying to do now. I always like inputs welcome. Any questions? What do you guys see? What do you think that is this something that we can take it further? What would be the next steps for our MVP? Because we wanted to make a progress, right? So what do you guys think?
Well, thanks, Sam. I think a few people are working on localization part of it. So I don't know if we want to work on like a functional block. So we get everybody running, get everybody with localization done, get that working.
Yeah. I see the most work over here at the path planner, the GUI, and what actually, and the work, I can see some work over here at the actuation system, where we have to actually convert all of our messages into an actual PWMs or whatever, the microcontroller that we use in between, which should work, and we should be able to calibrate it, whatever the actuator system that anyone would use. So I know that we'll need a lot of help over here in terms of GUI and the path planner. The LiDAR, the part is just actually, it would be the way we wanted to use it, would be really easy. Just mostly for the obstacle detection kind of, the purpose. So with that and e-stop and the remote, the e-stop would be the physical, like a stop and on the vehicle, and the remote kill is as you can do it through whatever the remote communications that you have, you want to stop it like from remote, the places, or for that matter from anywhere if you have the long range, the system that you want to put it on. So I'm really worried about some of these parts where we need a lot of inputs, but you're right. The IMU and GPS, once we have the localization done, at least we can see the vehicle, within the RVs, and then I think that's a progress for us.
I have a question for you, Sam. So for the actuator system block, how is the MVP going to address that? Because since everyone will be using a different microcontroller, as like in this community, I know people who are using different microcontrollers. So how does that? How is the MVP going to address that? Will the MVP just have choose one of these options and just use that, or is it going to be supported by different, or all of them?
So honestly, I have not thought about the whole part, but at this point, all I know is as long as we are able to produce the PWM output using any microcontroller of your choice, we will stop there, because you might use anything for your actuation. So be it, you're using the stepper, or maybe it's just a simple, the linear actuator, or could be anything else. So as far as we're concerned, I'm thinking at this point that as long as we are able to produce the PWM, the signal, it can be calibrated. That's what you need if you wanted to use, like, for example, I see that some people might have the clutch, right? And then they wanted to actually also put in the clutch, just not the brake steering and the throttle in many cases. But that would add some complexity. It's a good question. I don't know at this point that what can be done, but I think we wanted to stay kind of minimal at a point where we should be able to give you the PWM output. That's what I'm thinking right now.
Thanks. Also, a comment on the LiDAR system. If
Yeah.
you're aiming for a minimum viable product, adding a LiDAR would just make the computation super costly. Just my views on that.
Totally agree. I was thinking about it. I mean, there are like lidars now that actually, the range that I'm thinking about right now is like at least about 10 meters. And then we have the lidars like for about 40 meters. But you're right, that would be computational. Computationally, that would be a little bit more burden on what we do. So what do you suggest?
Well, sonars maybe, if it's a minimum viable product, like I don't know, or just eliminate the whole block. Well, it wouldn't have any obstacle avoidance, but at least it would be able to navigate.
A bumper with the limit switch.
Works, I think.
Anything that would stop, we need some system where your vehicle should stop within the safer distance, So.
Also, I was reading more about Pure Pursuit since it was mentioned a lot, and I think Pure Pursuit has this option to integrate a LiDAR or something. But so I think in that matter, for that matter, most path planners they come with this feature of obstacle avoidance in build if you have the input to it. So it's just a matter of hardware, and I think it would just increase the computational requirements a lot. So maybe we can have it like an optional feature, but in terms of minimum viable product, I think it's best to use something else.
Yep.
Yeah, maybe optional.
Or maybe optional.
Yeah, I think that's all I have for this. I think it's a great direction. Thanks for letting it all out. Also, can you? Will you be sharing this on the Google Drive as well, or is it already on the Google Drive or something?
Yeah, it's already shared on the Slack.
Okay. Yeah. Yeah, because I can definitely use those tables that you made. It would make thinking a lot easier.
Thanks. No, and obviously, guys, and I need more inputs. Like obviously some of the things that I will refine it over time. Everything over here might not. Something that I can already, and I'm already thinking about that. There are a couple of things that are already redundant. So I will be refining it over time, and then I will actually post the new version every time I refine it to the our Slack Google Drive. So if you just wanted to check it out, you can actually get it from there. But I wanted to go for every system. I wanted to go through this exercise, and we just wanted to make sure that we have all the info that we need. And then we can ask the right questions. That's what I feel. So, and then we can always, there's delve in the detail. So once we get into the detail, obviously we will not have time to go back and then change the overall framework. So we just want to make sure that when we start working, we start working at this level. So it means that right now we got some good inputs, right? That the LiDAR, it's just obviously we can make it optional. We should have IMU and GPS and coders, and obviously we're just making it optional because it's not available all the time. And actuating, and that's a good point, if you can, so and anyone else, Matt, Al, Tyler, the actuation system, how we can generalize it, you know, for most of the people to be able to use it with whatever's the controller that they have available at hand, you know. So be it the Arduino or ASP8266, 32s, any board, you know, that you might want to use with stepper, linear actuator of your choice of actuating system.
Excellent. Thanks, Sam. Appreciate that. We're running a little bit long tonight, but thanks for doing the project updates. It's always interesting to see what people are working on. And Colin, I'm really glad to see you on here. I'm glad you made it. And Kyler, your video is awesome of your tractor.
I get to see it.
It didn't hit anything, fortunately. It almost did. It was a good dry run.
It's awesome. Good work. All right. I hope you guys have a good week, and we'll see you back here next week.
Thank you. See you all.
Thanks, Matt.